All right, now if I can live up to all that. Um, but thank you, Tony. Yeah, so when Tony's talking about the curiosity, what was really inspiring to me. So my wife and I were just here Sunday, and I was going to give a whole new another presentation. I said, no, 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 it's got to be this. So, but I had bits and pieces of the science of what was happening at Mount Wilson. But going through the official tour, it was like 2.5 hours. I learned a lot both on the engineering side and science side. So tonight is just going to be science side. I'm not going to go into the engineering. If you want me back, I'll take you through the engineering because that is just as fascinating. So yeah. So the other thing that I thought was pretty cool, and a lot of you probably know this already, is that the Mount Wilson has a really heavy Chicago connection, both from scientists, but also from Yerkes. And we'll show you how all that ties together. So yeah, so we have the Hale Yerkes, and we'll get into all that now. And the reason we have that is from this incredible man, George Ellery Hale. And of course, he's from Chicago. And he founded, and many you know, probably Yerkes Observatory. Yerkes holds that 40-inch refractor. That refractor is never going to get bigger, from my understanding, as far as building a new one. That was the limits. That's kind of why he decided to go into a different direction with technology. Yeah, and then the last bullet, of course, is you have the roots, and I was shocked to find it out that the Chicago Astronomical Site has been around since 1862. That's incredible. So keep it going. So as we go on tonight, I think I need you to stop and put aside what you know about what we have learned, and step back in time to around 1900 and think about what did they know scientifically about the universe, right? They thought the universe was the Milky Way. They thought the sun was in the middle of the Milky Way, right? Um, they didn't know. Then they saw these other things that were nebulae, but they really weren't, right? So that's kind of where the background of all this, and where Hale comes through and just blows open the science in astrophysics. So nobody knows what the sun's made of, why it even shines, right? We take all that for granted because we know all this. How big the Milky Way, or they're thinking how big the universe is, whether galaxies exist, and even magnetism. They had no idea that there's magnetism beyond, our Earth. So in the next 30 years, because of Hale, we learn how stars are made of mostly hydrogen and helium. The sun's magnetism is measured by some of the instruments and we'll get into that. It's the sun again. It's kind of a Copernican thing. The sun is not or the Earth isn't the center of the solar system. Well, the sun is not in the center of our Milky Way galaxy either. It's in the Orion arm of the Milky Way. And we find out not only is there not just this Milky Way, but there are multitudes of galaxies. And all this comes from what they've discovered on Mount Wilson through the various telescopes there. Now, Hale himself wasn't just an entrepreneur for astronomy. He also was a scientist, and with his spectroheliograph, he was really the first one to photograph the sun in one wavelength of light. He founded the Astrophysical Journal, which I had no clue, which is kind of if you'll excuse the term, the standard candle of astrophysics. Um, Again, he discovered that there's magnetic fields on the sun. We'll talk a little bit more about that. And this was new to me. I didn't know there was a 22-year magnetic cycle. You know, you always hear about the 11-year sunspot cycle. Well, there's the magnetism shifts in the sun, as far as my understanding, from top to bottom and back and forth. So, unhappy with just a 40-inch scope, he wants to go bigger, and his father gives him the blank for a 60-inch scope many years before this telescope is built. Then that wasn't enough, and he builds the Hooker telescope, which is the 100-inch, which we'll have lots of pictures of. And then he starts work on the 200-inch, which is named after him, but he did not see it open. He died like 5 years before it was finished. But he is the single force behind all these things in Mount Wilson. And without him and some of these other scientists, which we'll talk about, you know, what we learned through that would come much later in time. So, and all that has the Chicago connection. Yay! All right, so when we think of going up to a mountain, like I was going to show you a video of me driving, and my wife Val has the phone out the window, and we're going around these turns as fast as I can take them safely. Nice paved road. They had none of that, right? All they had was some modified Indian trails to walk up. So it's really, I know this border's not on the science, but the engineering side of things. But I'll show you a bigger picture later. Next slide. That will show you the trail a little bit better. But this is 4,800 feet to 5,000 feet up, right? And you're taking these little trails, and think about all the equipment that they're taking, especially at the beginning, on these trails that are this wide. So it's mule driven. So it's really an incredible story when you think about it. And then they eventually widened it in order to get these trucks that could haul the mirrors up and the other concrete and all those other things. Yeah, so a close-up of that picture. You have the trail is still there. So that's quite far out. So it's it's winding its way up. It's not straight up and down. It took them a month with mules to get from bottom to top. So here's an example of a mule train going up. All right, so on top of Wilson, there are 3 sets of solar scopes, which is very interesting to learn about. Again, there's no such thing as a solar scope at this point in time. The snow one is horizontal, and it was very interesting to go in and tour. I'll show you some pictures of that. Some really good work was done there. Then they decided to build a 60-foot scope, and how's it up there? Anyone have any idea why they would do that? Yeah, so if you're on especially on a parking lot, right, and you have your telescope, you see all the heat plumes coming off and whatnot. It's trying to get away from that, that kind of heat, the heat stuff on the bottom. And then the 150-foot came 7 years later. And that was fascinating to tour as well. We'll get into that. So this is the SNO telescope, and it was built horizontally. And this roof would roll back, and they had it in operation, which was nice. And it would hit a mirror, hit another mirror, hit the third mirror, and then go down into the spectroheliograph or spectroscope. And so here's a picture that my wife took of that, doing that, and she AI'd all the stuff that was in the way out, which was pretty cool. But this was built in 1905. It was funded by Chicagoan Helen Snow, And it really showed, Hale a lot of new scientific data, including sunspots, which were cooler. He found out they were cooler than the surrounding surface. Now, these are all things we take for granted now, but you know, this is groundbreaking discovery at the time. Yeah, so here it is again, a wonderful, not the tour guide, but a presenter here. So that's the last mirror coming down, and you're looking. You can look down into the slot and see the spectrum of the sun, the visible spectrum. So here's your view. Some of the different colors that we see in our spectrum. But what we learned from that, or what he learned from that, was composition, temperature, the motion, even, and magnetism of the sun all became understandable and readable. So really started a whole new science at this point, right? Just on the solar side of things. Yeah, true. And well, yeah, we'll get to that later. So the 150-foot scope is really fascinating. Just a brief, uh, yeah. So, standing underneath, it's pretty incredible. Um, the Steve Padilla, who was the presenter at there, he takes this twice a day. He goes up on this elevator, positions the roof, for the next set of tours and whatnot. So we got to see him go up for the next set of tour. It's pretty neat. What's that? There's a little elevator on the side. We couldn't bribe him to go with. To go with, we tried. Um, yeah, so it was, if I do the engineering thing for you, I got pictures of that too. So, but you can see off in the distance, we're just starting our tour. The 60-foot, which we didn't view, and there's the 150-foot on the right side. So the reason it was built is to get, all the way out of the hot optics, of course. But what happens is the light travels down to the tower. And what's really cool from a science point of view is that they have kept records all the way from that time up until today, and they still keep them. And they're hand drawn of the sunspot activity, and they'll put them in archives, and those archives are then referenced by other scientists, later on. So it's the home of the longest solar records ever kept, and it's still going. And it's not just a tower, but it goes pretty far down into the ground as well. And that allows the, to, I'm trying to remember how big was the sun on the table that was coming back up, and it was pretty significantly sized. And you can see the sunspots on there, and then he does his drawings based on that. So that was kind of neat. And the other thing that was really cool as part of the tour, in 1948, they had a massive eruption of solar activity, which would happen today, which would cause catastrophic damage to the satellites and probably the electrical grids now. And he had the models of like Jupiter and Earth on there. And some of these sunspots that they've recorded are bigger than Jupiter, which is, really kind of incredible. Yeah, so the spectrograph part of it is down here, and I don't know how it works, but it comes back up, and they're able to study it up top. So we just saw the visual part of it. So here's Steve with his drawing for the day. Yeah, so he just traces it in pencil. But I thought, boy, wouldn't that be cool to do for a month? I don't know if I'd want to do that endlessly, but that would be a fun thing to do. Now, from a science point of view, that's all that is going on there. There's a tape room that's in the back, which they kind of have, these old computers, tape-driven computers and whatnot. So they don't have the funding now to do any more science than the sunspot and um, spectrosity. Yeah, so yeah, the whole mountain is not funded by government at all. It's only based on donations and whatnot. So I mean, if we talk to them about what it would take, to get this going to science again, well, probably more money than you have, you know. All right, so let's go on to the 60-inch reflector, and another uh, groundbreaking, not just from a science point of view, but it's also groundbreaking from an engineering point of view, which I'll just touch on briefly. So it sees first light in 1908. And like I mentioned earlier, the glass disc was a gift from his father. And some of you may recognize that name, George Ritchie. Um, so you have the Ritchie, or is it Ritchie, Cassegrain, right? The RCs. So his design ideas from even back then are still being used today in both professional and amateur um, community. And when we, the science behind some of the things that they came up with is really amazing. So even today, it's one of the two largest telescopes open to the public, and it was really impressive. So just to give you an idea of how big this thing is, the mirror, of course, is 60 inches, but here's our Michael, our tour guide, and it's gargantuan to stand under. Um, but what is really neat about this telescope, it has three configurations. So it has the Newtonian configuration, and right now it's in a Cassegrain configuration, and they do it by swapping out the second tier of that structure to reconfigure it. And then the third one, unfortunately, I don't have a picture, but down the side of it, they have a spectrograph um, uh, configuration for it. The one piece I thought was really amazing was that because it floats on Mercury, the mirror, you're able to take a normal clock drive to drive this whole thing. So it's a significant clock drive. It's about this big, but it's because it's floating on that Mercury, it lightens the actual weight of the scope, and you can thereby it's able to turn. And that was I don't know. I think that yeah, you wouldn't want to swim in it or anything. Well, it's all enclosed, I imagine, but I don't know. I don't know how that part of it works, but I'll find out for sure. So, again, looking up into that lattice work, um, it's hard in a picture to really, feel the monstrosity of this, and this isn't even the biggest one. So the 100-inch Hooker telescope, and it's named after its funder, Joseph Hooker, I think. I'll have the slide up there that says. Uh, but again, they wanted to do more. Your Hale wanted to do even more, and more is indeed what happened. And I'm sure a lot of you are familiar with Edwin Hubble and his discoveries, but there's a lot of other discoveries that happened too with this scope. This one, it has this double harness thing, and I don't know. It's hard to explain just how gargantuan this thing feels. At the bottom of it, they have this four-inch refractor, which they have it configured to look through. And I got a picture of me pretending to look through it. But anyway, so not only was it the largest, but it was the largest for 3 decades. which is pretty incredible to think about. So in 1917 is when it saw its first light. There's a whole story behind the mirrors. They actually built 9 different versions of the mirrors, and they all ended up going back and taking the third because that's the best they could do for it. That's fascinating. I can't imagine how much money they actually went through in today's dollars. So everything that moves in this, including the dome and the telescope, it's 1,000,000 pounds. So, so the science and engineering behind this thing to get everything to move is just kind of crazy. Yeah, you can look again. This has different configurations. They have platforms up there for the reflector view, so you're way up high to look into it there. Um, Again, this floats on Mercury bearings as well. And of course, this is the instrument Hubble used for his amazing discoveries. Now, when we were there, the dome was closed, and the engineer comes gingerly up and says, "Is it okay if we open the dome and move the telescope?" And everybody's like, "Yeah, yeah, please do." And they did. So I got a little video. I don't know if the sound will come through, but it looks like the telescope's moving with your eye. Maybe not, but it's the dome that's moving. And if you look at it at this view, which I have a longer video of, it looks like the telescope's moving around and the dome is still. But yeah, I mean the sound too is like brrr, this thing going. But that was really thrilling to see it open and close. Uh, so that is not a typical tour attraction that you get. So I was very thankful to have that. Uh, Again, this is an engineering thing, but the same machinery is still running this thing today. So 100 and so, thank you. Even more, right? Yeah, crazy. And again, you have to be there to really appreciate it, and I would encourage you to visit. It's tremendous, and take the tour. It's only like $20 or something, and if you're over 62, it's even cheaper. So, all right, so let's get into the discoveries that kind of rewrote everything when it comes to astrophysics. Um, from Leavitt's ruler, which is not necessarily part of Mount Wilson's history, but without her, Henrietta Leavitt, none of the stuff that Hubble does and forgot Shapley can be done without her. And unfortunately, as we know, women weren't given the opportunities in science like they do today. So she was never even able to use her rule, which was to measure the Cepheid variables. She wasn't allowed to work at a scope, and here she is. So back then they would call the humans the computers who were doing the calculations and whatnot. But the ruler is what everybody would use even today as far as measuring Cepheid variables and their true brightness. Now, okay, so Harlow Shapley was really he went into the discipline of just examining globular clusters. And he just wanted to understand where they were in relation to where we are. And because of his work, he said, whoa, this globular cluster is way over here, and this one's here, and this one's there. And by doing all this, he was able to say, hey, you know what? The sun is not in the middle of our Milky Way, right? It's over on this other part of it. So another, how do I say this nicely? But prideful view of what we are on Earth, that the Earth is the center of anything, kind of goes up in vapor. But he also, by doing this measurement of these globular clusters and stars in these globular clusters, he begins to map out how wide our universe, or not our universe, but our galaxy is. And, it's way, way bigger than anyone had thought. They were, I think, if I remember correctly, they're thinking the whole galaxy was 10,000 light years or something across. And that's not even a blink of the eye. So Edwin Hubble, is really the centerpiece of discovery for science of the time. So this little display there was on display at the Smithsonian for 25 years. And then I guess they no longer wanted it. So they have it on display on the second level. So you take, I don't know, I tried to count the steps, but then I ended up talking. But it's something like 40 steps to the second level and another 40 steps to get up to, the base of where the telescope is. But yeah, so this was the actual piece he used, and the glass plate goes up there. And you might see some pictures of him sitting there. And of course, those were staged, for what his discoveries. But yeah, so that for me, that was really thrilling to see. Yeah, so Hubble's biggest discovery using that ruler rule was the variable Cepheids that he found in the Andromeda galaxy, which at that point was what? Wasn't a galaxy in their minds. It was a nebula, right? It's just another part of the Milky Way, right? So by measuring it, it changes everything. And here's his original plate that he took, and up high it says Nova, because that's what he originally thought it was, and then later on he writes in big red letters VAR, so it's a variable Cepheid, and he realizes that this is a galaxy on its own right. So in 1923 was the first time that humanity thought or knew that there were galaxies beyond our Milky Way. So can you imagine Hubble, figuring this out? No wonder he wrote it like that. Who do I tell first? And eventually, he gets Einstein up there, and Einstein, does away with what's the part of his equation he does away with? Yeah, the cosmological, the fudge factor thing. By the way, you may have heard that he said that it's the greatest mistake he ever made in his life. Secondhand information. So he might have said it, but we have no proof that he said it. So, but that's not it. Both Hubble and, I looked it up, Hummingson. I looked it up, now I forgot what it was, how you pronounce his name. What was it? Hummingson, okay. They started to measure the redshift. So not only was the universe much larger than they thought, but now they're measuring, hey, things are redshifted away. That means they're moving away from us. So now they discovered that the universe isn't static as well. So, again, imagine thinking that the universe is static and you're coming across these discoveries and that, this stuff is moving away. Some of it's moving closer to us, like Andromeda is, we know. So pretty exciting stuff. Now, what's really interesting about Hummingson is, look where he starts. He's a mule driver, works up to janitor, and he works up to being a scientist. I don't see that happening today. But there are people out there who are capable of this, but they're locked out because of the way we do uh, scientific validation for people to get into the business, yeah, degrees like Einstein, right? High school education. Anyway, so expanding universe, recording over multiple nights. So they would take a plate, right, and record for hours, put a shutter over it, take it out the next day. You remember how some of us used to guide, with these reticles? That's the same thing they do. Keep a reticle on a star for hours on end, to do these hour-long exposures on these plates. So yeah, here's Einstein coming to see. Hubble is right there in the middle. Walter Adams is there taking him on the tour. So that must have been pretty thrilling for Einstein as well. There was also another man, Walter. Oh, I looked this up too. Baade. Um, and he was important, and it was also important that he was German, and World War II breaks out, and they said to him, "You can't. You have to be in at night. You can't leave the confines of where you are." And Michelson championed it to allow him to work, and because he did, Baade's discoveries happened. So, and one of those was that they realized there's more than one type of Cepheid variable, and so the distance scale was off, right? And so they were able to narrow down the scale factors of everything. So yeah, lots of folks contributing to astrophysics in a way that was never seen before, and it's all because of one man had a vision to build these monstrosities of telescopes. So later on, Michelson, who I mentioned before, and Pease, Michelson, University of Chicago, right, builds this 20-foot interferometer on top of the 100-inch, and they measure Betelgeuse, or Betelgeuse, however you want to pronounce it. I've heard that both is appropriate, but your mileage may vary. Do you know how big Betelgeuse is, or Betelgeuse? What if was it? Yeah, Mars orbit plus and plus some. It almost reaches out to Jupiter. Yeah. So you put it in our solar system, we're gone, right? And it's a variable star too, right? It changes in brightness. So up until that time, stars were just unresolvable points, but now they were able to detect the size because of what they were doing with this Hooker telescope. Now, in the later years, like 2004, we didn't really get to tour any of this, which was fine because we were spending a lot of time in the 60 and 100-inch, which was fine with me. But the Georgia State University is running these 6 1-meter telescopes together, and this kind of blows me away, right? You can resolve a nickel at 16,000 kilometers with it. And I won't get into the engineering of that, why that is yet, but so yeah, they're still measuring the surfaces of stars today. So there's a lot of professional work still going on top of Mount Wilson, and that's great. All right, we're getting to the end here. When we pulled up, and when I pulled up into the, they have 2 parking lots, so I wanted to pull up into this lower one, and we parked right at the edge. And believe me, when I say edge, there's no coming back from going over on this side here. But you can see these are all burned here, right? So if you remember, we had the two fires there. The Eaton fire, which they really were wondering if they're going to be able to save everything on Mount Wilson, but that's how close it came. Was the second parking lot, and they have an on-site fire team there who are there all the time. So thankful that the fire did not get there, and we are able to see all this beauty of technology and science. Yeah, so there's a bigger version of it. There's a hiking trail that goes down there. That's what these folks were coming up from a hike. I forget what city that is down there. Yeah. So, yeah, that's kind of the rapid fire. So I don't know, Tony, do we have time for questions? Or all right. I'm also afraid to say I don't know the answer, so not afraid to say it. Yeah, go ahead. There's a story about the 200 engineers who passed the coin last week in New York on a fire accident. Second was the first crack. Yeah. So like, you know, it's the 100 plate. Yeah. Which was kind of interesting. I didn't show it here, but the Michael, our guide, put a laser up on the bottom of the mirror of the 60-inch, and you could see all the bubbles, in there. It was that was pretty cool. I don't know. That will be my science talk. Yeah. Yeah. Right. Hale was impressed back in 1912 by a talk by a fellow named Besto Melvin Sniper of Lowell Observatory, who had checked out some. This is ridiculous. He had spectra of galaxies with a 24-inch on old plates. These require 2 nights of 7 hours guiding the scope for that exposure. You get 14-hour exposures in Flagstaff weather, which is extremely cold. To give you an idea of how cold, Chicago's record snowfall was 89 inches. That's the average snowfall of Flagstaff. So it's a very cold environment, but he was able to weather that. That's one of the reasons why Hale decided to go Edwin Hubble as his man, because Hubble was one of the original masters of the Midway. Right, right. Chicago's basketball. He's a really big, strong fellow. Isn't that interesting? Besto Melvin Sniper, he got use of a Lowell scope because Lowell only was there when Mars was within about 8 weeks of an opposition. Because Mars otherwise wasn't all that much clicking. Yeah. So he had it all the rest of the time. Eventually, he told it for Lowell, and he's the one who hired Ty Thompson. Oh, wow. Yeah. Interesting. Yeah. Yeah, go ahead. Oh, I don't know the thickness. 4,200 pounds, though. I don't know. That's a good question. That's all part of. I'm intrigued by all this, so that's why the engineering side. I'll do the research on that stuff. Yeah, that'll be part 2. One person I left out, which for us amateur astronomers is significant, is E. Barnard, right? And he is famous for, well, Barnard star, but which Tony will get into later. Yeah, so he's the one who cataloged the Barnard catalog, right, and all the dark nebula, right, and he was the one who discovered that these were not voids in space, but there's actually dust, right, and he worked at Yerkes, and he worked at Mount Wilson, so there's another connection there, between them. Anything else?
Go online and show us some of your astronomical images.
Do I have? Does this have internet? Yeah. Yeah, that was going to be my original talk, but this was far more fun. Yeah, so if you can see that, let's see, what do we want to do? Yeah, so, okay, so this is from 2018. This isn't anything new. This is when I got back into the hobby. That's in Sedona with a DSLR. But, okay, I have a telescope in Starfront Observatories down in Texas. So here's a time lapse. Mine straight is right here. If we could go out, you can start to see the Milky Way coming overhead there. Anyway, there's some more recent stuff. Yeah, of course, yeah. Galaxies. Oh, hey, this is a good one. You talk about a stroke of luck. So I don't know if you heard about the supernova that happened in the splinter galaxy, NGC 5907. I happened to be taking the picture the night it went. I'm not the discoverer or any of that, but I did catch it. So you talk about dumb luck. That's pretty dumb luck. Okay, so well, here's a good one. Okay, so all these PGCs, they're all galaxies. We're talking 100 to 300 million light years away. But boy, the resolution on this PC is not great. All right, so Andromeda. It's just a 61 millimeter refractor doublet with a corrector on it, so nothing really special. But it's a lot of hours. Like, well, this one was only almost just 4 hours, but M51. Boy. Yeah, it's ripping the little guy apart. So yeah. Oh, one more I want to show you. Not galaxies. Gallery. Oh, here. Yeah, that's the row of, help me with the pronunciation. Fukai. Yeah, so that's a 2-panel mosaic. It's something I always wanted to do. I couldn't do in my backyard because I have no southern view in my backyard. But down there, I can do that. That's about, how many hours of this? Did I calculate it? Oh, Ashley, nice comment. Yeah, I don't know. I think it's close to 35 hours of total imaging time. So anyway, all right.
Um, do you have any images of planets?
Ah, planetary is a whole nother animal, which I will be tackling soon. But I have one from it's not handy. I took one of Jupiter through my LX200 on Kodachrome 400 film back in 91 or something when it was 5 degrees in Galena. I still remember that. Caught a cold. Yeah. So that's the only one. Oh, no, I do have a Saturn. I do have a Saturn. If it was dark. It was dark. Well, yeah, I mean, M4, which is part of that row complex there, that's near the Antares, if in Scorpius. Yeah, so that would be very easily seen. Maybe not quite in this detail, but what else? Yeah, everybody, right? We all know the Great Hercules Cluster, M13.
Point out galaxy in the small cluster.
Now, have you seen that in the scope? That's kind of cool. You can see M81, M82. Yeah, this is a good one. Which one, though? So that's the Markarian chain of galaxies, right? So this, you could see a lot of people go through this on their Messier marathons. There's 4 Messier, 88, 87, 86, 84. Does everybody know the story of Charles Messier and why he's so famous to amateur astronomers? I'm saying that for my friends who are here who have no idea. So Charles Messier was a comet hunter, and he'd scan the skies, and these objects kept getting in his way. So he cataloged them, and that catalog ended up becoming the famous catalog for amateur astronomers to look at things. Not for the reason he created it, because we're not looking for comets, but all these great 110 objects are there because he cataloged them because they were in his way. I just think that's a funny story. What else, Tony?
How about the Veil Nebula, the Cygnus?
Okay, I think I have that one. This is the Orion Nebula and the Horsehead. That's a 3-panel mosaic. This is a lot of hours. I think that's close to 50 hours of imaging time. And of course, our Orion Nebula, it's a unaided eye. Yeah, you don't need binoculars even to see it. These kind of look smudgy in a telescope, but M81, M82. And what'd you say? Oh yeah, the veil. Oh, really? Yeah. So here's a typical Barnard object, right? That's the dark nebula. You can't get that from around here. I can't get that from my home in Batavia. You can't get it from here. It's just the filters can't deal with, the sensitivity of this dust. I haven't done the veil. Oh, here it is. Okay, let me tell you another story here about the triangle here. This just really kind of ticks me off. But so it's called Pickering's triangle because Pickering, a good guy, he was the head of the observatory that it was discovered at. Did he discover it? Wilhelmina Fleming, a woman, should get credit for that. So I don't call it Pickering's triangle anymore. I call it Fleming's triangle. Yeah, it's just like, oh yeah, I should get credit for that. You didn't do anything. Anyway, yeah, so that's the Veil Nebula. This is in a hydrogen alpha, oxygen 3, and sulfur 2 band pass. So all those band passes, our eye really doesn't pick up too well, if at all. So, but telescopes can, and the cameras. All right, Tony. Oh, you are a slave driver here. Oh, this was, how many of us go to Green River? Right? Yeah, so this was just with my little scope in Green River. But you can't even get the little bit of the outer shell in there. Yeah. Mm-hmm. Whoop, whoop, whoop. Yeah, that's a good object for visual. You get a decent sized scope, you can see that ring and the central star in the middle pretty well. Okay, Tony, I think it's your turn.
Actually, the weather is so extraordinary, I want to postpone my talk till next time because we're not going to get a chance to enjoy this weather like we got tonight. And also, we need to move on with elections. Right there. Is that correct? Elections tonight. I did not realize that. Okay, all right. Well, listen, I will then put it up for a vote because we do have extraordinary nights doing, and I would like to take advantage of this evening, get outside and enjoy the weather, and gaze at the first quarter moon. However, if there was protesting this, getting outside and enjoying the weather, I will torment you with my talk.
Second. Even though I can't vote.
So anyway, listen, Andy, I want to thank you for the talk. It was wonderful. And I hope that you can come and give us part 2, but let's give it Andy. don't say no.
Yeah.
It does look like the telescope moving. Which big one? This guy here?